Hi everyone, good morning. Welcome to the session. Welcome everyone. Greetings from Mercy Technologies. So this is Monday. We have done 1 week full of data structures course. Now with this fresh start of the week, let's see what is our agenda for today. So agenda for today is we'll be learning what is a linked list, how to represent a linked list, what are the best coding practices while you code in the linked list, how to traverse a linked list, how to find the time and space complexity, how do we analyze the time and space complexity in case of this linked list problems, and finally introduction to HackerRank, which is a platform we'll be using for practicing and coding the programs that we are learning as part of this course. So at this particular moment, I'd like to show how a data structure called linked list will be represented. So this is how it is represented. So there are three important points that are to be taken care in case of linked list. What is the first important point? The first important point is a head. The second important point is this box. This box is called as a node, right? This is the second one. And the third one is this null, right? So what is the significance of the three? Head is nothing but it specifies that it is starting of the linked list. So this head will tell us that the linked list is starting from this particular point and it will be moving forward. It will be moving forward. So the second important point is the node. Here I'll be explaining you in deep what is a node is, but from here in this diagram, what you will understand is node has two parts. One thing is data and the second thing is link. What is this link doing? This link is pointing us to the address of the next node, right? In the first node, what is the thing that we are having? We are having data. In our case, it is an integer data, which is 28. And what is the second part having? The second part is pointing us to one more node, which is having a data called 27. The same thing goes on, and finally at one particular node there is something called a null. What is this null saying? Null is saying that the data structure called linked list has been ended at this particular point, right? These are the basic things that are present inside a linked list, right? Now what we'll do, we'll try to understand what is this. The first part, the first part is nothing but it is a node. As I told you, data is one part in that and link is second part in that. So this total thing is called as a node. This total thing is called as a node. So the first part called data, it contains the actual data of the node. In our case, we have taken the data to be an integer. Here we are representing that as 28. And the next part is nothing but it is a link. What is that link doing? That is link is storing the address of the next node, right? It's storing the address of the next node. So this is what the data and the link, and this is the internal part. Now without wasting any time, let me straight away jump into the code and tell you how do we represent a linked list, right? How do we represent a linked list? For this, I'm taking my Eclipse. So what is my Eclipse doing? I've taken a class called node, right? There is a class called node. It has two parameters. What are those two parameters? Two properties, I can say. Those two properties are data and next. So as you know, every object that we are trying to create, like this class would be responsible. Class will be containing the data members. Those two data members are data and next in our case. So we need to initialize this. Here in our first part, what we have done, there is a node which is initialized with a value called 28. There is a node which is initialized with a value called 27. Similarly, to initialize that, we need to have a constructor. Here what I have done, I've taken a constructor of a single parameter, a parameterized constructor of single parameter. What is that? Data, right? And I have taken one more constructor. If I do not have it, then it gives some Java compile time. I mean, it gives a problem, right? Let's not dig deep into that. But here is a no argument constructor, and here is a single argument constructor. What is the single argument constructor doing? It is taking the data, in our case 28 or 27 or 26 or 25, and it is initializing that, and finally we are able to represent the node that we are seeing in this particular diagram, right? This is the class for that. Now, without wasting our time, let's directly go into code how to traverse that. So what is our first linked list doing? The first linked list in our representation, what is it doing is we are having a head, and that head is pointing to the next node, and that is pointing to the next node, etc, 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 right? Finally it is ending at null. So at this particular point we are trying to write some code, but before we try to write some code, I'll try to tell you what are the coding practices that we need to follow. What are the thumb rules, right? These are the thumb rules, guys. The thumb rule one says never modify head, right? What happens when you modify head, right? When you modify head, here there is a head. If you remove head, which means all this data, right? all this data all this data has no point of communication. Only when you have head, you do not have, you can traverse and try to print these values, but if you do not have an access to head, then all this data is somewhere lost in the memory. So that is why directly we should never do any operation on head. Instead we should take one more reference variable, so that if we do some operation on the head also, if we do some operation on the head also, it will not actually modify the head, but it will modify the reference variable. I will be showing the code so that you can get better understanding of that, right? So I was telling you the best coding practices. The first point we have done. And what is the second point? The second point is you have to handle the boundary conditions. Boundary conditions are nothing but they are dealing with the null values, or they are dealing with the empty values. I told you linked list node is a Java class representation. When there is something called as a class, when there is an object, then there are very likely chances that it can be null, right? So in cases where node can be null, we need to understand that we need to handle that condition. And there can be cases where your linked list can be empty, and even in those empty cases you need to make sure that you are handling those and finally writing your code. So with these two thumb rules, let me try to make you understand what is our first code. I'm just removing this main method. And finally introducing you to this particular method I'm trying to write here. So what have I written? I told you in our previous classes that by seeing at the method signature, the interviewer or the person who is reviewing your code or the person who has given you an exam should understand that you're trying to do something in this method. When you see this something called linked list traversal, so by just seeing this, you are able to do one thing. What is that? You can able to understand that inside there should be some logic, and what will that logic do? It will try to iterate your linked list and try to print something, right? Try to print something. So here what I have done, I've taken a method signature, I mean a method name which is good, you can understand just by seeing its name. And what is the input parameter for that? The input parameter for that is head. I told you that when you have the access to this head, only when you have this head, you can actually move further, and finally you will be ending up in null. So what is our input that we are giving? We are giving input as head, right? Input as head. So I told you, so this is the first thing. And after that, I told you in our best thumb rules for linked list data structure, the base condition should be handled. What is the base condition? The null condition should be handled when head is equal to null, which means when you are passing a null linked list, so you cannot print anything, so there's no point of even coming into your logic. So what am I doing? I'm returning from here itself, right? So I'm done with that. So after that, I told you we should never modify the head directly. So that is why instead of modifying the head directly, I'm taking a reference variable called p. Okay, you can take whatever name you are comfortable with, but here I'm taking a reference variable called p and initializing that to head. So whatever is the modification that I do, I'll be doing it only on p, right? So here what I'm doing, this is the actual heart or logic of the program that we are writing. So what is that? we are doing, while p is not equal to null, we are trying to print the value of p, and we are saying p is equal to p dot next. This small code should be printing every value. Okay, so in our case, I told you I'm removing the main method, but let me print that again. So what I have taken here, I've taken here a node head. So head is pointing it to what? Head is pointing to 28. So after 28 is pointing to 28, initially what I've done, I've created these four nodes: head 27, 26, 25, node 27, node 26, node 25, right? I've created nodes. So after that, I'm saying head dot next is equal to node dot 27, right? Head of next is equal to, this is head right now, so it is pointing to 27. So what is 27 pointing to? 27 is pointing to 26, right? 27 is pointing to 26. So that is why node 27 dot next is equal to node 26. Similarly, node 26 dot next is equal to node 25. So at this particular moment, somebody has asked me a doubt that should we write this line, node 25 dot next is equal to null. Node 25 dot next is equal to null. Even if we do not write this line, it will be by default node 25 dot next is equal to null. The reason is, what we are doing as part of node 25, we are saying node 25, we are initializing that with the value called 25. So what is node here? Node is having two things, which is data and next. So data, we are passing the value as 25, but to next we are not passing any value. What is this next? Next is of type node. When you are on not passing any value, by default the object's value will be null. So that is why I'm not bothering about writing this line of code, but even if you write, that's fine. So that is why I have commented this part. So at this particular moment, what I'm trying to do, I'm trying to call this method and try to execute our logic, right? Try to execute our logic. Let me try to run this code and show you how it goes, right? Here's what it is. So our input, we have taken an input now 27, 28, 27, 26, 25. So this is what it is: 28, 27, 26, and 25. So this is the expected output, and finally we got the output, we printed that, right? Now, let me try to explain you by dry running this code, right? How to dry run this code? What is dry running is just nothing but you have to write it on a piece of paper or write it on on notepad or somewhere, so that what happens is you are making sure your code is working fine in all the conditions. So here I'm taking the language to be Java so that the look and feel is good. So here what I'm trying to do, so let me try to print the output, right? Let me try to print the output. Here the output is, so output is something that we, okay, we are trying to print the output one by one by trying to go line by line in our code. Now let's try to take what is the actual representation. Representation is nothing but head is pointing to what? Let me maximize this. Okay, representation is nothing but we are taking, representation is nothing but we have head head is pointing out to what? Head is pointing out to 28, right? Head is pointing out to 28, 28 is pointing out to 27, 27 is pointing out to 26, 26 is pointing out to 25, right? And finally 25 is pointing out to null, right? 25 is pointing out to null. So what we'll do, we'll try to dry run this code. So what is the first thing which is saying? I'm giving the input, I'm giving the parameter, input parameter for this one as head. But what is head in our case? Head in our case is 28. So is head null? No. So that's why we are not coming into this condition. We are going to line number 4. So what is line number 4 doing? Line number 4 is creating a node with the name P, right? Let me do that. So there is something called node called P, and it is pointing out to head, right? It is pointing out to head. So what is pointing out to head? P is pointing out to head here. P is pointing out to head. While P dot next, P is not equal to null. Yes, P is not equal to null because P's value is 28 right now. So P is not equal to null. What we are doing, we are trying to print, we are trying to print P dot data. What is the P dot data in our case? P dot data in our case is 28, right? It's 28. So here what I'm doing, I'm trying to print some space as well, right? Some space as well. So I've taken a space as well. Now, as part of, so this is done. This two lines of code are done. Now it's coming back to the while loop. Again, it is checking if p is not equal to null. Yes, p is not equal to null. So initially, previously, after printing this, what we have done, we are doing this p is equal to p dot next. Now what we are doing as part of that, p is moving to p dot next, right? So this is how it is moving. Now the p's value is at 27. We are trying to print 27, and the next line, what it says, p is equal to p dot next. So p is coming to 26. P is coming to 26. So you're trying to print 26. So what is the next thing that you're going to do? Again, it's going back to this, the while condition. So after printing 26, you're moving it to 25, going to the while condition, checking it's not null. So you're printing it's 25. So after that, again, you're moving that to null, right? You're moving that to null. But here, if you see, P is not equal to null, right? But in our case, at this particular point, P is null, right? P is null. So when P is null, you're trying to come out and there's nothing more. There is no more code for you to dig right now or write right now. So you have written a code which will be printing all the numbers that you are giving as the input for your linked list, right? So with this point, we are able to understand how to write a simple code and how to represent the linked list and how do we write a code so that we can traverse the linked list and print the output, right? At this particular point, guys, let me try to tell you one thing, right? Here, let's say the input is having only 4 nodes, right? Only 4, 1, 2, 3, and 4. So there's no point of learning data structures when your input is so small, like 440, 400, 4000, something like that. When your data is growing in millions, when your data is in billions, only then you have to handle these conditions. That is why you're trying to learn what is space complexity, time complexity, etc., etc. The reason why you are learning is because the data could be so big, but we are taking simple data here. What is our simple data? Our simple data is just 4 nodes. But in real time, or in the places where people try to assess your program, they should be giving, or they should be testing your program with so much big input. Only then they can conclude your program is running properly, right? But for example, let's say I want to test your code with some 300 linked list with length 300. So what should I do? I should be initializing 300 times this node, and I should say dot next, dot next, dot next. So which means these are 300 lines and these are 300 lines, which is almost 600 lines of code you should be writing, right? You can even write a method for that. I don't say it's wrong, but the thing is, it's your responsibility to give the input, right? But our intention of learning data structure is not how to write or how to give the input. The intention is to write, to know how the logic is written, right? So let's not concentrate on this part, because we'll be unnecessarily breaking our head for that. So that is why we need to have a platform so that we can test our code with different test cases, different inputs, different ways of testing that. So for this, I'll be introducing to our platform, which we'll be using as part of this course, which is called as HackerRank, right? Let me open up HackerRank. How do I open up HackerRank is, I'm going to Google, right? I'm going to Google. I'm trying to type something called HackerRank linked list traverse. Okay, so this is what I wanted. I get my first link. I'm going and opening that first link, right? After I open that first link, here I have already solved this problem, but I want to show that to you again. I want to show that to you again. Just by seeing our simple problem, you should be in a position to answer this problem. I'm just removing whatever the code that I have written here, and I'm pasting it somewhere so that it can be handy if something goes wrong, right? So what is happening now? What is happening now? So let's try to understand um, what is the problem statement here. You can read it out, but I'll tell you. here what it says, there is a sample input and sample output. What is the sample input saying? Sample input is saying I'll be passing you a linked list of length 2 and it will be having data of 16 and 13. So when I give something like this to you, your output should be 16 and 13. You just need to print 16 and 13, right? This is what is written in this explanation, right? This is what is written in this explanation. So let's try to implement the same code that we have written in our Eclipse, in the same in HackerRank as well. But here there are two differences that you need to understand. What is the first difference? The first difference is I have represented the node with the name called node, but this HackerRank guys, what did they do? They have represented that with a name called singly linked list node. That's fine. They have used that naming convention. So we have used this naming convention. It's up to us, but that is fine as of now. So what is the first step that we need to do? The first step that we need to do is, if we are checking the base condition, right? So what is the base condition which is saying? If we are trying to check head, right? If head is equal to null, what am I trying to do? I'm trying to return it from here straight away, right? Trying to return. That's it. We are done with the base condition. Now let's try to move. What did I say? We should never modify the head, right? So what did I do? I'm taking one reference variable of type singly linked list. So I'm naming that as P and I'm initializing that to head, right? I'm initializing that to head. So as part of this, what we have now, we have a reference variable called P and it is also pointing to head. Now I'm trying to run the code. So what's happening now? While P is not equal to null, So what am I trying to do here? I'm printing, let me copy this code directly. I am printing the value of P, right? I'm printing the value of P. So what is the next step that I'm doing? P is equal to P dot next. So that's it. I'm doing P is equal to P dot next. So with this, I'm done with writing the code. The same code that I've written in Eclipse, I'm writing it here, right? I'm writing it here. So let me try to run this code and show you how it happens, right? So this is how it is. So you see this, there is a wrong answer. The reason why there is a wrong answer is because I copied the code from what I have written in our Eclipse directly here. In our Eclipse, I tried to show you an output of this particular way, right? How did I show the output? I'm showing the output on a horizontal way, 28 followed by 27 followed by 26, and there is a space inside. But here, what they are expecting 16 in the next line 13, right? This is what they are expecting. So that is why instead of making it as print, I'm making it as println. What println does, println tries to print the data in the next line, right? Tries to print the data and the cursor will come to the next line, right? So after that, by modifying this, let me try to run the code again. Wow, now it's done. We are able to submit the code and it says congratulations, right? We are able to do this. Now, this is the simple test case called 0. So it has the length of 2 and it has two values 16 and 13, and finally the output is this. The sample test case 1, what it says, the length is 4 and these are the 4 elements that are present, right? And our output is also specifying the same thing. Expected output, this is your output and this is the expected output, and both are same. So these are the simple two test cases, and fine, we even got the congratulations message saying that we are able to do it in a proper way. Now let's try to submit this code. When I try to submit this code, there are various test cases which are coming up, right? There are various test cases which are coming up. So let's try to understand this. Test case 1 and 2 we have already done. Test case 3, it is having the input as 31 and these are the inputs, and our output is also fine, right? There is test case 4 which is having the input, the size is 31, This is having the size is 100, which means 100 data it has. And then in this case, okay, it says we need to spend some hackers, find 289, so almost 300 is the length of your linked list, and your program is running fine without any exceptions, right, without any problems. So here it is almost 500 is the input size, and your program is running fine. There's no problem, even if the data is, even if the input size is getting increased, right? Even if the input size is getting increased. So with this, what I want to understand is, guys, HackerRank is not very hard as many people think. HackerRank is a very easy platform. So we just need to figure out the logic that we are trying to write. Try to use the same naming conventions that those guys are using, and try to figure out or write our logic, and finally run our code and submit our code, and that's it. All right, and that's it. So here, let me introduce a little bit more about HackerRank platform as well. So what is that? It says this is what your submissions. I have done this many submissions for only this program till now. So this is what it says. It is accepted, and the score is this one, 5 out of 5. We got the marks of 5 out of 5. So what is the leaderboard? Leaderboard is saying here, this person, this is me, and this person is leading right now. And there is one more guy is leading, right? There are other people who are leading, right? So this gives you the leaderboard, country wise, etc., etc. What is the language that they are using? When you go to the discussions tab, there will be people who will be discussing. Let's say this is a very simple problem, but there are problems which are very big and hard to understand as well. So for those, there are people who actually discuss more on this, and so that you can participate in this discussion and try to gain more knowledge as well. You can ask even the questions, and there are people who answered your questions as well. So, and then there will be editorial. The person who is the editor, or the person who has given this problem, will be the editor for this, and he'll be giving you the finally summarized code or the best code as part of the discussion. And finally, he'll be summarizing all that in this editorial. Let's say he's writing that on C++ or C or Python or whatever is the language. There are ways. These are simple small codes, guys, and you can take those codes and you can use your convenient language. In our case, since we are doing that in Java, so I've used Java 7 for my submission. So here we can use different languages. These are the languages that it is currently supporting, right? So with this, whatever is the agenda that we try to do has been done. So here I'm taking a small analogy, guys. What is the analogy for that? Analogy is nothing but I just got this picture somewhere in the YouTube, sorry, somewhere in Google. So what it says, linked list data structure be like, I know a guy who knows a guy, right? The same thing. Let's try to uh, this is just for you guys to remember. That's it. What is 28 node saying? I know a guy. So who is that guy? 27. So I know a guy named 27, and this 27 instead, or in turn knows one more guy, kind of. So it's like, it's not 28 knows 27, but it's not like 27 knows 28. The reason is, like, there is no point from 27 to 28. There is even one more data structure which is called as double linked list. We'll be seeing that as we move forward, but single linked list says I know a guy who knows a guy, and the guy in our analogy is nothing but the node, right? Let me move back. What we have done, we used the thumb rules today. What are the things that we should never forget, and how do we need to handle the base conditions? And here we have explored the HackerRank platform, and it's easy and convenient to use with our first program. So guys, I'll be writing the notes for you. I'll be giving you the notes. I'll be sending you the link for the problem that we have solved today. We'll be doing step by step. We'll be solving it one by one. So as we move further in the classes, we'll be solving more and more complex problems, and finally we'll be getting acquainted in this platform. This is very important. The reason why it is very important is, most of the companies will ask you, the first thing that they'll ask you is, they'll be sending you a HackerRank link, and you need to pass that test so that they can call you for the interview, right? For you to pass that, you need to be familiar with this platform, and you'll be familiar only with practice, right? Only with practice. Data structures is of two things, guys. First thing is, like, you need to practice a lot so that you can build up your logic. You should first practice on paper, and after that the next thing that you need to do is you need to practice that in HackerRank, right? You need to practice that in HackerRank. There are chances, or there's no point of practicing that in Eclipse. The reason is like you have to write all this input on your own hands, but in HackerRank, the input of 450, 500, etc., etc., is already written. The only thing that you need to concentrate is the logic. The only this from line number 5 to line number 11, you have written in HackerRank, you have written only the logic in HackerRank, and finally it took care of everything that you're trying to write in it. So with this point, guys, I'd like to say that I'm going to end this session. So you need to do your homework. People need to register on HackerRank, and they need to take this problem as an example. They should solve it, they should be taking a screenshot, and you should be posting that in our group. So one more important thing that I want to tell at this particular moment is you need to practice it in the daily basis. Never try to pile up your previous day's homework, because I'll be going in slow and steady manner. So if you follow the class thoroughly and if you do your homework regularly, so which means you are in a correct position, and you will be in a position to understand the class, the next day's class, in a better manner, right? With this particular thing, guys, let me try to end up today's class, and I expect you guys to practice a lot and improve yourself a lot in data structures. Thank you.